Hello, welcome to our podcast, Stack More Layers. The idea behind it is to present a realistic approach to artificial intelligence from AI practitioners' perspective. In Coffee Talks series, we want to discuss recent events, things we believe are important or maybe trigger us somehow in the world of AI. Today I will be talking with Barbara Rychalska.
Hello.
And Łukasz Sienkiewicz.
Hi.
And the starting point of our conversation is reproducibility crisis in science caused by misapplication of machine learning algorithms or some errors in machine learning pipelines. And the scientists from Princeton University recently investigated several hundreds of papers were from different domains of science where the machine learning algorithms were used, and they found errors in over 300 of them. And yes,
that's amazingly great number. I think no one expected that.
Really, was it so that unexpected?
Well, if you knew the older research on reproducibility, for example, from the medical field, you might know that this John Irani, this guy, a famous researcher, was focused on verifying the validity of medical papers. He found that depending on the study, but 40 to 90% of medical articles had some issues, which doesn't mean that all of them are fake or false, but they contained, for example, some methodological flaws, or they had too weak evidence for their claims. So if you knew that, I think, yeah, you would say, well, that's what I thought.
Yeah,
but
exactly.
But when we are in this field, like we both, and Maria also, we are in the field of AI and ML, and without seeing the numbers before, because this is the first study that actually did this, I think we are quite amazed, to say the least.
Yeah, and I think that it is important to note that, well, we have to separate two things here, because the errors which are intentional due to, I don't know, some sort of and there are unintentional errors, simply errors, intellectual errors, one may say. So they even found out. At least I read one article on this topic when I was preparing for this conversation, and one of the authors found out that he himself, in his paper, in which he collaborated with other people, also made some errors, and obviously these were methodological errors about which he was not aware. Because otherwise he would eliminate those errors. So it's when we are concerned with these unintentional errors, it's very difficult and very subtle to eliminate them. And well, that's very challenging, I think.
And can you elaborate on the intentional errors?
Well, intentional errors are due to the fact that science in general is some sort of social practice. So there are companies who are funding science, and sometimes they would like to pursue their own agendas. Yeah. For instance, there is this famous case concerning anti-global warming. There are some serious scientists who are who thought that climate change is not caused by our industry and our technology. Some of them obviously are sincere and, well, they're serious scientists, and, well, they just have some arguments. Maybe they are wrong, maybe they're right. But we also know about about some of the papers or some of the scientific institutions which were founded by oil companies in United States, which were interested in, you know, denying the fact that climate change is caused by our human actions. So, so this is one, I think, the most the most important, or the most that's one example of this intentional
I
error.
think that a large part of the intentional errors are caused by private initiative. So on the one hand, we have indeed the companies that want to push their agenda in order to better sell their products or continue their industry and so on and so forth. But on the other hand, we have the individual scientists who face a really stressful environment in the academia. And this phrase, to publish or to perish, is 100% true. I think that from my experience, I would say that academia is more adversarial and stressful environment than industry, and by a lot. Although you might think that, well, money isn't involved, right, in academia, so why? In the industry, you need to earn money, so that's where you should be stressed and fighting and aggressive and so on. But I think in academia, it's like they have extremely small resources that need to be divided into a large pool of participants. And these resources are grants and money for research in general. So they have enormous the need is there for fighting and taking all that you can do to succeed, because there are so many people who are trying to get a piece of the cake that with connection to the fact, for example, in the ML conference world, the rate of rejection in the most prestigious conferences can be more than 80%.
Oh.
Up to 90%, right? I saw many conferences that had 9 or 8 acceptance rate. So imagine this: you are working on something for half a year, let's say, and you get the article out, and your chances of failure are 93%, let's say. And the output is binary, so you don't get partial success. For example, if you have a product, you sell it on the market, you will earn some money. Maybe not so much as you wanted originally, but you will earn some money, and you can then go on and maybe make it better or just work on this. While in academia, the output is pure binary, so you get a rejection and you have nothing. And if you get in, you have everything.
Well, you can go to less prestigious conference, for instance, or send your manuscript to less prestigious journal.
And then the review process takes 3 months per conference, and for a journal it can take more than a year. And then there is another rejection, for example.
Yeah, that's right. It's very frustrating.
It's extremely hard for the human psychology to live in such environment. And I think many of the people who do it maybe do it because they think it's the only way to keep above the surface and to survive, simply because I don't want to, sound it like it's justified, because it's not. But I just want to say that it's an incredibly adversarial environment.
Yeah, that's right.
Okay.
Especially if someone is at the very beginning of his career, because he does not have well-established position in the environment, in the society, in the
and there is this problem then, because he or she needs to invest this half or 3 months time into preparing the publication themselves, usually, because when you're a professor, then your PhD students and your co-workers usually do the core work, the everyday work. So you don't have to do it yourself. You can have multiple papers running, and you just supervise, right? Not that it's so easy to supervise, but you don't have to write the code, run the experiments, and work, I think, more than 10 years a day, usually, to get this done. So these people really really put in extreme amounts of time, and they are poised for failure because of the acceptance rates, basically.
Okay, what I see here is that we started to talk in like more general way, like this
we deviate somehow from this main topic, which was machine
no,
learning.
actually, I meant that you just provided some broader like context for the reproducibility crisis, where ML wasn't even included, because the example from the industry and the example from academia, I think, are something that is not only related with machine learning. So yeah, that's interesting that. Or while this discussion is focused on machine learning, we can see that there is a much broader problem.
Yeah.
And how do you think it applies to machine learning? Yes, both in this academic point of view, or maybe what are some specific issues with machine learning caused reproducibility crisis?
So certainly there exists this intentional component in machine learning too. But putting this aside, let me focus on this unintentional. So sometimes, well, this we are talking about in a break about this data leakage. Yes, that's an issue. The other issue that
can you elaborate on this, because maybe not everyone knows what's data leakage.
Sometimes it's just it can take many forms actually. So one of the forms is, for instance, that you have, in machine learning we divide our data sets on trained sets and test sets. We train our models by means of this train set, and then we evaluate them using this test sets. And sometimes there is, in general, there could be some information concerning test set which is included in this train set. So this is the problem of separation. It is very hard to completely separate information between these two. So
maybe I will add, why is it important? Because we need to check if the model is able to generalize to unseen data. So we need to separate data seen in training from data we test model performance on, because if we would test on the same data, it may be that model trained data by heart and is unable to solve the task, so it's unable to generalize. Yeah, continue, please. Sorry.
Yeah, it would be good to provide some very illustrative example, but I don't have such example right now. It would be probably
of data leakage from
some simple, straightforward example of data leakage. For instance, there is actually one example. Suppose that we train some model which we would like this model to predict something about some data series, and then we use in train set we use some data which is so that some test data is previous in sense of time than this train data.
Yeah.
Therefore, we will have some kind of leakage, because we will know that model somehow could memorize the future, and in some sense it could predict the past using the future, which is not the thing that we would like it to do. We would like it to just predict this time series in order to predict the future based on the past.
So a sort of temporal leak.
Yeah, temporal leak.
I think there are many variations where this could happen, and although it might seem that it's easy to actually say this is my test set, this is my train set, they are separated, it's not easy in practice, because all kinds of maybe more subtle ways that it can happen are very much happening. all the time. For example, there can be a case where we're learning something based on the history of what some people are doing. For example, a paper might try to do splits based on this data set. And in the splits, we might get the same people on which we have trained in a way, but in the test set, they might have a bit more history. So the history could go a bit further in time. However, they are still the same people who we learned on. So if the setting is, and the other papers that are testing, they, for example, thought about it and they excluded these same people from the test set because they thought, well, we have seen them. We know them already, right? We know Maria, what she does, and we don't want Maria in test set. So this other model gets an unfair advantage then. Although it's actually different data because you have new events coming from for these people.
Yes, so it's not always so obvious, and in all of these cases we are
Actually, in most cases, it's non-obvious.
yeah, we are getting like over-optimistic results. But I also read about this much more obvious mistakes where, for example, the feature selection is conducted on whole data set. So feature selection is selecting features that, or the pieces of information based on which the model is solving the task that works the best for this model. So if we choose these features on the whole data set, and we then separate for train and test set. So the test set was included in the procedure that was part of maybe not training, but model design or anything like creating model. So that is like more obvious mistake that is also made sometimes. So that's another.
Yeah, some feature that really gives you the answer right away.
Which is actually it's equivalent in some sense to the answer, and therefore the model is not that interesting because.
So the example that we had, I guess, was about some disease like hypertension.
Yeah, the example with hypertension is in feature engineering. When you are, it can be done when we are not even feature selection because there is automatic feature selection that is done based on data, and but also this is feature engineering, which is done by a person who is taking data set and deciding which feature to use. And one mistake that we particularly liked because it was a bit funny is in the model that predict hypertension in patients. They used the feature if patient is taking antihypertensive medicine. So the model was predicting hypertension based on.
It's so obvious that I doubt that it's really unintentional mistake because it's so straightforward that this is error that.
No, I think it could be unintentional because I think one of the claims behind this thesis that this theory that ML is because I've seen this phrase, ML is causing the reproducibility crisis, like as if it hasn't been there before. And it was, obviously, since the dawn of science, it was there. However, I think this premise is born from the fact that actually when you haven't done any data manipulation before, you haven't done any AI and machine learning, nothing like that, use things like, for example, data robot for maybe more a corporate example, but people do it every day. So they just take a table full of data and they put it there into the machine, and they don't really reason a lot about what is in the data, what logic could there be, what errors are in the data.
But this feature
And
was
it's an
engineered by
automatic.
someone, so someone put some effort in order to create such feature.
Okay, I'm not sure if it was engineered,
Because
but maybe
it
he
was
just
okay.
took the data set
Okay,
and
if it was,
inputted.
Yeah, if it was in the raw data, then it's okay. Then someone could omit the fact that it is there.
Maybe
And
this
that's
one-
also a very serious mistake that
Yeah.
you have data and in this data you have something which is that's
Yeah.
To explain, raw data are data before any pre-processing steps.
Yeah.
So the data as we get it, you download, I don't know, a CSV file, and these are raw data, let's say. And another example of this not being careful with data is the COVID prediction based on X-ray images. Where all images of COVID patients came from adults, and all images of pneumonia and no COVID patients come from children. So the model just learned to distinguish adults from children based on X-ray images. And not to predict COVID. And this mistake was caused by, I think, not paying enough attention for the source, for the data. To the data source and data characteristic, because probably researchers just took some set of X-ray images from one source with pneumonia and some COVID images, and they didn't make an effort to see like if the distribution is not somehow skewed, Yeah, so this is another example.
Yeah, so it's. I would not say that this is. What are there any issues which are specifically related to machine learning? Because this could also happen. I mean, 100 years ago, when someone used just some linear regression or some
statistics even.
Some
without
statistics
any learning.
without any. Yeah. Now we have these models are due to the development of computational resources. These models are much larger, much more complex, and so on. And people a few decades ago didn't have access to such computational power, simply to these computational resources, and so they could not even imagine that one could use such a model. But these errors look very similar to the one that people made few decades ago or even 100 years ago. So it's is there something really which is really specific to modern machine learning?
Maybe one fact could be specific, and the fact that experiments are easier to conduct in AI. So when you run some clinical trials and you follow people for 50 years, and you have a very limited set of people that you have access to, or you have some rare disease, or you need to have expensive equipment in your laboratory to run an experiment, the barrier for replication, I think, gets higher. And it's not so easy to organize a thing like this reproducibility challenge that's in ML. So here, when you have open data sets, you have computers that maybe not everyone has at their home. Because when you think about the hardware that the big labs have, they have really amazing resources. But still, there are a lot of institutions who can do it with very easy, I think, very easily. And I think that's one way why actually it could be easier to push forward with the study in AI.
Okay, but I have sorry for interrupting, but I have the counter argument, because in medicine it may be much more complex, but I don't know, maybe in psychology sometimes to conduct a study it may be comparable with an effort you need to put in creating AI algorithm, train it, and make a prediction based on it, or even sometimes to do this right and to avoid all these mistakes. It may be, in fact, much more challenging.
Yeah, and also not very expensive, maybe. However, I think that the machine learning community is kind of more dynamic because the people are present all over the internet, probably more than psychologists. I don't think that the psychology, the area is so centered around the internet, and the fast exchange of knowledge. So that's also a characteristic from our field that makes it more likely to correct itself, I think, more dynamically.
Yeah, that was my... sorry.
So you're more on the optimistic side that this else could be eventually corrected in some way.
Yeah, I think now we're sad because we've discovered the problem, but discovering the problem is the core prerequisite to solving the problem.
Yeah. I think that this problem is quite natural.
It's hard to solve.
Yeah, it's hard to solve, but it's also natural that since the field grows, and it grows enormously in recent years, I'm coming back to the beginning of our discussion. It would be very silly to think that since this field is growing, that the problems which are typical for statistics, for fields which heavily rely on statistical methods, that the issues that these other fields have will not simply occur in this highly and very dynamically growing field of machine learning and artificial intelligence. In particular. So
I think the bottom line is we want to say there is no fault in ML specifically in fueling this crisis. It's simply a field that has reacted to this.
Yeah, okay, so when we are on the topic of reacting to this, what do you think can be done to increase reliability of results?
Well, it's the hard thing, right? Because the incentive in science is that you have this image of a brilliant scientist who comes up with brilliant ideas, and for this you are rewarded in this world. So you're generally rewarded for bright ideas that work, and you are not rewarded for testing someone else's work, because the current world of publishing is about obtaining some new results and introducing some new methods which are interesting and kind of push the boundary forward. They push the science forward. There is the more mundane fact that scientists deal with is that they need to publish in prestigious venues like prestigious journals and conferences, and for this is something we call in Poland the point gathering, because you get a sort of either imaginary or factual points for publishing in this sort of venues.
Yeah, there is even official lists of our Ministry of Education, it's called, and they publish. They publishing a ranking of this journals and conferences, and each has its determined number of points.
And currently, right now, as far as I know, there is no high-ranking venue that gives you points. For testing others' work.
Yeah, it's very interesting. There is a few years ago I watched some YouTube videos with lectures of Polish psychologist Tomasz Witkowski. He has PhD in psychology, and his main goal and main aim as a scientist was to I don't know how he called it precisely, but to clarify and clean all this psychological research, which he considers as not very well empirically verified, because a lot of in psychology this problem is gigantic. So yeah, and so he dedicated his career to informing people about this problem, about some problems concerning empirical evidence of effectiveness of various forms of psychotherapy and so on, because in general, he considers some sorts of, for instance, psychotherapy as harmful for individuals.
Is he accepted by the general psychology,
I think that he is a middle-aged man, something about he's 50 years old or something like that, and he still only has PhD. So perhaps
Probably
it is some.
They don't consider it groundbreaking and so on and so forth.
Well, because he didn't bother to to try to make any progress, because he thinks that the progress in psychology now is it is very difficult to make any progress, since there is a lot of rubbish articles, rubbish research
on bad basis.
Yeah, exactly. So if your assumption and premises are flawed, then it's very hard to try to research something based on them.
Actually, I remember one guy who published this kind of research. It was in machine learning and it was in recommender systems, so the area that we all work in. And his name is Dietmar Janach, and he's from Austria. And he and his colleagues, they have a series of papers which show that the recent deep learning recommender systems were actually also based on a false promise, because they were comparing against themselves, and they were kind of advancing over previous deep learning recommenders. However, when these guys introduced simpler baselines, such as nearest neighbor-based, really simple recommenders, they found out that these extremely simple recommenders outperformed a great majority of these deep learning approaches. And it was actually published, I think, in the Rexus conference, which is a pretty large site for this topic. However, nothing happened. He just published
There was no reaction.
And I don't think anyone uses these baselines that he proposes, and they were just continuing on their path of advancing one over the other.
Okay.
And also, I think he wrote that he couldn't replicate a large number of these papers at all.
Okay, so two things I heard here is the first one was that one way to eliminate mistakes is to learn what kind of mistakes we are making. So, and that it's not happening really much right now. So this investigation that we're talking about is a good sign, actually, because we are finally getting to know the mistakes. And the second thing is to making the maybe methodology more rigorous, or maybe some, as you told, some baselines and benchmarks that helps us to compare results in a uniform way. Okay.
Maybe also encouraging some people which would like to, dedicate themselves to the topic of reproducibility. Encourage them to pursue this goal, because it's very from the practical point of view it is very advantageous for the whole scientific community.
But my question now is, okay, so we have these people, let's say, that are committed to spotting these mistakes with reproducibility, and how to enforce the correct behavior because we may have all the mistakes well known, and how to make them not how to enforce the right methodology, and
how to fix this whole problem.
how to fix it.
Yeah, so I think that the incentive is the key maybe here, because people like any organism just going where the incentive is, right? And right now I think that in the field of AI, at least, we have a situation like in the 19th century Europe and the industrialization era, when everything was wild and people simply converged to this extremely abusive systems of people working their lives away at factories for 20 hours a day. So it's not always true, unfortunately, that given the freedom, extremely, uncontrolled environment, you will get the right behavior, the one that's optimal for all. Because I think that all kinds of extremes develop this way if you just give a free rein to everyone. This sounds like control, which is bad for me personally. I don't like this idea of control. However, I think that something indeed must be made from the top to the bottom to make this happen. And I thought about this a bit. And maybe one way would be to include this reproducibility challenge as a valid track at major conferences, because right now it's just some initiative. And frankly speaking, although my methodology was not correct, I admit, I was simply checking for some papers that were submitted to this reproducibility challenge. I haven't seen the major labs there. I saw some guys from Europe or from India, but not from the big guys. So the proportion of big guys at the NeurIPS or iClear or something was a lot bigger than in this reproducibility challenge. Yeah, so the ones that really have the resources to do it, they weren't there. Although I can admit that I haven't looked at all of these papers, so maybe they were somewhere there.
Of course.
So I think that the track which goes to the proceedings and gives you the points and whatever you need for your academic success should be given for that. And maybe also some form of an automated repository where you get a sort of a call for reproducibility for papers which are often cited. So they are influential, people rely on them heavily. So it increases their call for reproducibility. Then when you reproduce them, you provide some kind of verification, and the score can be lowered. And then your lab also can have a quota of these points of reproducibility.
Yes, some sort of community voting.
Yes, it has to fill this quota every year, for example, in order to get some perks. I don't know, to be able to publish at a conference or something like that.
Very nice.
Yeah, I think it's very interesting because we have here maybe we are coming to an end of our discussion, so I'll do a quick sum up. So from this solutions that you provided, one group was based around this responsibility of researchers and how to invoke this and this feeling of being responsible. And you pointed out some big players that produce a lot of results, breakthroughs, but are not so interested in this methodological issues.
Yeah.
And other thing is to use already existing scoring mechanism and incorporate this reproducibility somehow in this existing mechanism. That's very, very interesting idea.
We have to face the fact that there won't be any fame and glory in reproducing. So that's why the big guys don't go in this direction.
Yeah.
There will never be, okay? But we need to do it for the good of everyone.
Yeah.
Yeah, I think that's the great conclusion, and thank you very much for the conversation, and see you next time.
Thank you.
Bye.
Thank you. Bye.